Hey guys, welcome to day 3. Today you're going to learn all about conditional statements, if, else, elif, logical operators, code blocks, scope, global and local namespacing, and a whole lot more. And by the end of the day, you will know enough to be able to build this awesome choose your own adventure game. So this is what it looks like when it loads. And our mission is to find the treasure. So it tells us you're at a crossroad. Where do you want to go? Left or right? Let's say I want to go left. You come to a lake. There's an island in the middle of the lake. Type wait to wait for a boat. Type swim to swim across. I'm going to wait for a boat. You arrive at the island unharmed. There's a house with 3 doors, one red, one yellow, and one blue. Which color do you choose? Let's choose red. And unfortunately, it's a room full of fire. Game over. So this game lets the user make decisions, and depending on what they've chosen, it continues the game storyline. If you want to have a go at this game, you can head over to treasure-island-end.appbury.repl.run and have a play around with the game. And once you're ready, head over to the next lesson, and we're going to start picking up the skills that's going to be required in order to build this game. So I'll see you on the next lesson. Here's a question. Have you ever sat in your bath and wondered, why is it that no matter how forgetful I am, my bath never overflows like this? This is something I was thinking about the other day. And I realized that it's not because I'm particularly diligent. I forget stuff all the time. I mean, pizza, anyone? It's what my pizzas usually look like. But the reason why our bathtub or the sink doesn't overflow is because of this fantastic piece of engineering, the overflow. So this means that whenever the water reaches beyond a certain level, about here, the water starts overflowing so that the bathtub doesn't overflow and annoy your neighbors downstairs. In fact, we could represent this mechanism with a conditional statement. When the water level is, say, greater than 80 centimeters, then it should drain the water. But if the water level is not greater than 80 centimeters, it should continue filling up the tub. This type of conditional statement is known as an if-else statement. Depending on a particular condition, we would do either A or B. And when we want to write Python code to represent this, it looks something like this. There's the keyword if, and then the condition that we're testing for, and then a colon. And after the colon, we've got an indented block of code, which should be executed if this condition is met, if it's true. But if it's not true, then we will skip to the else block, and it's just the else keyword with a colon. And then this code block would execute if the condition is false. So we could represent that previous bathtub situation with code that looks a bit like this. Let's say our water level is at 50 centimeters, and then we would test if the water level is greater than 80 centimeters. Well, if that is the case, then we should drain the water. But if it's not greater than 80 centimeters, in other words, else, well, in this case, we should just continue filling up the bathtub. Let's put this into practice with a real life problem. Now, let's say that you've gotten a job at a theme park, and your first job of the day is to write some code that replaces the ticket box. Now, there's a couple of things that you'll need to think about. Firstly, in order for somebody to actually purchase a ticket to go on the roller coaster ride, they will need to be over 120 centimeters. So we have to check what their height is, because if they're too short, then we won't be able to sell them a ticket anyways. In the course resources, I've included a link to this flowchart that I've created on draw.io. This is a really, really useful tool for creating any sort of flowcharts or diagrams, and it's really easy to use. Now, if we take a look at this flowchart, this is basically the logic that we have to program using our if and else statements. If the person who's trying to purchase a ticket is not over 120 centimeters, then they can't ride on the roller coaster. But if their height is greater than 120 centimeters, then they can ride. So let's try it out. If you head over to the starting replet you'll find some starting code in there, and you can go ahead and fork this replit. All that I've got here is a print statement that says welcome to the roller coaster, as well as an input asking the user for their height in centimeters, and then converting this string into a whole number, an integer. And then I'm storing it inside this variable called height. Now we're going to check whether if the height that the user has typed in is greater than 120. So we use the keyword if, and then we check if the height is greater than 120, and then we add the colon. And now when I hit enter, you'll notice that the code editor has automatically indented me slightly over. I'm not over here, because in Python, the spacing and indentation is really, really important. It tells the computer that the code that I'm about to write is what should be executed when this condition is met. So what should happen? If your height is over 120, then we will just print, you can ride the roller coaster. But what should we print if height is not greater than 120? Well, in this case, we would use the else statement to catch when that happens. And it's really important that you don't write the else here, because this is indented over. Instead, you want it to be at the same indentation level as the if statement. These two are essentially a pair, if and else. Now, after the else keyword, we again add a colon, and then we hit enter, and we're now indented again. And here we can write the code that should happen if this condition is false. Sorry, you have to grow taller before you can write. So the really important things here are the condition, which we're testing for, is the value of height greater than 120, the syntax of this code, so the keywords if and else, as well as the colons that come after each of these lines, and finally also the indentation. Everything that is indented after the if is a block of code. So this is indented and it's effectively inside this if. So this line of code lives inside the else statement. This block of code lives inside the if statement. And if you mess up on the indentation, then you're probably going to get an indentation error telling you that this line, 5, probably should be indented. But when we do actually correct it and we hit run, let's say that our height is 130 centimeters. Then we get back, you can ride the roller coaster. But if our height was, say, 90 centimeters, then we get a different outcome. We get, sorry, you have to grow taller before you can ride. So by using if and else statements, we're able to get our code to do different things, either printing this line or printing this line, depending on a condition that we're testing for. Now, when we use this greater than sign, effectively what we're saying is that is the height greater than 120, which means that it does not include 120. In fact, if I run this code and if I type in my height as 120, then it actually goes into the else block and prints this. So if we wanted to include 120 centimeters so that all the people who are exactly 120 centimeters can ride the roller coaster, then instead of just using a greater than symbol, we have to write greater than or equals. So these two symbols have to be next to each other. And now when I run my code and I write 120, you'll see that it's now falling into this block of code and it's telling me that I can ride the roller coaster. Now these are called comparison operators, and we've already seen greater than, so lesser than is pretty self-explanatory, but we've also seen greater than or equal to and lesser than or equal to. So if you want to include a particular number or a particular value, when you do these comparisons, you would be using these instead. Now in this table, there's also the equal to and not equal to. For example, if you wanted to check if somebody's height is equal to precisely 120, then you would use two equal signs. And very often it gets a little bit confusing, especially if you're new to programming, when you're typing equal signs, because sometimes we're typing 1 and other times we're typing 2. It's important to remember that when you have one equal sign, it means that you're assigning this value to this variable. But when you have two equal signs, you're checking to see if the value on the left is equal to the value on the right. And they're completely different. Now, the good thing is that when you get it wrong, usually you'll get enough clues in the error to actually hint to you, hey, maybe there's something that's wrong here, right? Because the syntax doesn't look right. For this to be a condition, it has to be something that evaluates to true or to false. And height equals 120 does not evaluate to either. So by changing it to this, we're saying if height is equal to 120, then we'll execute this line of code or any other lines which are in the same block of code. But if the height is not equal to 120, then we're going to execute this block of code. So if I write 120, then that works. But if I write 121, then it does not work. Similarly, you can also check for not equals to, which just flips it around. But in our case, it makes sense to say if the height is greater than or equals to 120, then you can ride the roller coaster, but otherwise you cannot ride the roller coaster. By using if and else statements, we can get our computer to do different things and respond differently depending on different conditions. So in the next lesson, I've got a coding exercise for you. I'll see you there. All right, guys, it's time for yet another code challenge to test and see if you've learned what was covered in previous lessons. So head over to the assignment that is day 3.1, odd or even. Have a read of the instructions and try to see if you can create a program that checks whether if a number that you input in the console is odd or even. Now, the thing to remember here, though, is that we're introducing something called the modulo, and you can create the symbol by simply typing the percentage sign. Now, what the modulo does is it will divide a number, say 7, by another number, let's say 2, and then it'll give you the remainder of that division. So 7 divided by 2. 7 split into portions of 2 is 2 plus 2 plus 2 plus 1, right? So 7 divided by 2 can be divided 3 times with a remainder of 1. And that's what the modulo gives you. So you can also type code straight into the console, like I am going to do now. 7 modulo 2 gives me 1. Now, it's the same thing if you try to divide by other numbers. Let's say 7 modulo 3, well, that is 3 plus 3 plus 1, right? So 7 modulo 3 will also give me 1. So this is a way for us to divide a number by another number and get the remainder. And you're going to be using this modulo to solve this code challenge. Have a read of the instructions, have a look at the examples, and see what it is that we're expecting to be printed in the console here. And then go ahead and write your code and see if your output matches what it is that we're expecting. So 56 should be even, so you should be printing this is an even number based on that input. Pause the video now and give this code challenge a go. All right, so I mentioned that the modulo gives us the remainder, right? So what do we know about even numbers? Well, even numbers, they're always divisible by 2. If we pick any even number, say 54, and then we do modulo 2, so 54 divided by 2, it should always give us 0 as long as that first number is even. So 68 modulo 2, again it's 0. But then when we come across an odd number, say 53 modulo 2, then this is now going to give us 1. We can use our code to check for when the result is 0, in which case it's an even number, and when the result is 1, in which case it's an odd number. if you've gotten stuck until this point, then this is a really great time to pause the video again and go back and give it another go. And then we'll go through the solution together. We can simply write an if statement to check if the number that was inputted is divisible by 2 with 0 remainder. Well, in this case, then we can pretty much be sure that this is an even number, because as we've shown, all the even numbers, when they divide by 2, there's always no remainder. So in this case, let's add a colon. We can print pretty confidently that this is a even number. Now, what about the cases where the number, when divided by 2, is not equal to 0? Well, then it's probably going to be an odd number. So in this case, we can use an else statement to catch that. And when we have an odd number, we'll simply print this is an odd number. So that's it. Just 4 lines of code using what we've learned about if, else, and also the comparison operator. Now, if you got stuck on this and you needed to watch the solution, then I recommend really going back to your code and playing around with it so that you can get the code to work. And then try and see if you can test if a particular number is cleanly divisible by 3, by 4, by 5, and then see if the final program actually works in the way that you expect it to. But once you're ready, head over to the next lesson, where we're going to talk about even more complex ways of using if and else statements. So for all of that and more, I'll see you there. In previous lessons, we learned about using the if and else statements to check whether if somebody is over 120 centimeters or not, and allow them to actually purchase a ticket if they are over a certain height. Now, in addition to the height, there's another condition that we need to check for, namely their age. If somebody is over 18 years old, then they should be paying the adult price, which is, let's say, $12. But if they are 18 or under, then they should only be paying $7. So how can we represent this extra condition that we need to check for in our code? Well, we could use something called a nested if-else statement. We've seen our if-else statements look like this, where it's only got 2 choices. If this condition is true, do this, otherwise do that. But in a nested if statement, once the first condition has passed, we can check for another condition. And then we can have another if-else statement inside this if condition. In order for this thing to happen, this has to be true and this also has to be true. In order for this to happen, this condition has to be true, but this condition has to be false. So essentially, the computer first looks at the larger picture, which is this first condition, and decides on whether if it should go into the else block here, or if it should go into the nested block inside the if statement. So now this is what our flowchart looks like. In the first if statement, we check whether if their height is over 120 centimeters. If no, then the if statements all end. You can't ride, you can't buy a ticket. But if yes, we actually take them to yet another if statement where we check their age. If their age is 18 or under, then we give them a $7 ticket. If they're over 18, then they have to pay $12. So the place where we're going to nest our if statement is inside here. Notice how it's indented, so it's already inside this if block. And this already has to be true. Now here we're going to create another if and else statement. And the condition checks for their age. So we better ask them for an age. Let's say age equals, convert the input to an int, and what is your age? So now that we've gotten hold of their age, we can see if their age is less than or equal to 18, well, in this case, we're going to give them the $7 ticket. But else, namely, if this is not true, if their age is over 18, well, in that case, we're going to give them the $12 ticket. So now we have a nested if statement, because this if and else statement lives inside this if statement. So this condition will only be checked if this is already deemed to be true. Now let's say our situation got a little bit more complex. The boss comes over, checks our code, and says, wait, there's actually more price tiers than that. In fact, if you're less than 12 years old, you pay $5. If you're between 12 and 18, you pay $7. And if you're over 18, then you pay the full adult price, which is $12. Now, there are 3 possibilities. So how do we represent this in our if statement? Well, we could use something called the elif. Instead of having a simple if-else statement where there's only one condition, if it's true, do this, otherwise do that, you can add as many elif conditions as you want. So we can check for condition 1. If that's true, then do A. But if that's not true, then we can continue and check for condition 2. If condition 2 is true, well then we can do B. And finally, if none of those conditions were true, we can do this final thing. Our flowchart now looks something like this. And this is the logic that we're trying to program. Once we're inside this nested if statement, we're going to check if their age is under 12, in which case they should pay $5. If they're between 12 and 18, then they should pay $7. And finally, if they're over 18, then they should pay $12. Now, the first thing I'm going to check is if the age is less than 12. Under this condition, they should pay $5. So let's change that to 5. Now, the next condition should be created using an elif, which stands for else if. So it means if this is not true, else if, can you check if this is true? Well, in that case, then we should do this. For example, if the age is not less than 12, so they're over 12, then are they under 18? Well, then this condition basically catches everybody who's between 12 and 18. And finally, if they're not less than or equal to 18 and they're not less than 12, then that's everybody else who is over 18. Now, remember that we can use as many elif conditions between the if and else as we like. So I could add another elif that checks whether if the age is less than, say, 22. Well, in this case, do something else. And then I can keep going with these elifs until I'm done with all my conditions. So have a play around with this code, write it yourself, see if it makes sense, and then mess around with the elifs so that it does what you expect it to do. And then once you're ready, go ahead and head over to the next lesson where I've got a coding challenge for you. So now that you've learned all about if, elif, and else, as well as nested if statements, then I've got 2 code challenges coming up for you. In the first one, in the code challenge that's called Day 3.2 BMI Calculator 2.0, this is going to be an upgraded version of the BMI calculator that you created yesterday. Instead of just working out the BMI value of somebody, we're going to give them an interpretation. You might have come across a BMI chart that looks like this, where it divides up people's BMI and tells them whether if they're underweight, normal weight, overweight, etc. And this depends on the value of the BMI. So if the value of the BMI is less than 18.5, then they are underweight. If they're over 18.5 but below 25, then they have a normal weight. So your job is to not only create a BMI calculator, but also to give them the corresponding interpretation message. Now, it's really, really important that you use the words here that are highlighted in bold in your interpretation, that based on a particular height and weight, you actually give them the correct interpretation. Pause the video and try to give this challenge a go. All right, so how did you get on? There was a little bit of revision from what you've done previously. Hopefully you've been able to calculate the BMI without much trouble, and then use what you learned about if, elif, and else to provide the user with the corresponding interpretation for the BMI that they have. Let's start out by calculating the BMI. And the BMI, according to this equation, is equal to the weight in kilograms divided by the height squared. So we've got the weight already, and then we divide it by the height to the power of 2. Now, notice how I've already converted these inputs to floats, so we don't have to do what we did previously when we were calculating the BMI. Now, what the exercise does mention, though, is that we should round the result to the nearest whole number. But you probably remember how to do this, right? Using the round function. So if we wrap the entire equation inside a round function, then it's going to round it to the nearest whole number. So if this is what you got stuck on, then head back to your code and just fix it. Now, once we've calculated the rounded value of BMI, the next step is to give the user an interpretation message based on their BMI. So let's start with the first one. If the BMI is less than 18.5, well then in this case, they're actually underweight, right? So we'll print something like your BMI is, and then inside here we'll insert the value of their BMI. And this of course is using F strings, so let's add an F to the beginning. Your BMI is this particular value and you are underweight. Now, what if their BMI was between 18.5 and 25? Well, because we've already checked that their BMI is less than 18.5, then if this is false, because it's jumped to the next level, then we don't actually have to check this. All we have to do is check that it's still below 25. And to do that, we're going to use an elif. So elif BMI is less than 25, well, then in this case, we're going to print your BMI is this particular value, and you have a normal weight. If this is a little bit mysterious to you, why it is that I'm not checking that their BMI is over 18.5 but below 25, and I'm simply just checking that it's less than 25, then I recommend having a play around with the code as it is right now and trying out some different values for BMI. Just change this to say 18 and then try maybe something like 22 so that it's caught by each of these conditions. And then you'll soon realize that this if, elif, else is an entire group of statements, and it's going to check this one first, and only if this fails when it's false does it go and check the next one. So then this is only going to be printed when their BMI is over 18.5 but below 25. And once you're comfortable with this, then the rest of the statements should be pretty easy. Now, once we've reached here and their BMI is not less than 35, and we want to catch the remaining cases where the BMI is over 35, then all we have to do is add an else statement. That's all we have to do. We've managed to check for those people who have BMI less than 18.5. If it's not less than 18.5, well, is it less than 25? So this will print when the BMI is greater than 18.5 but less than 25. And we've done that for all of these separate statements. If you struggled with this code, then I recommend having a look back at the previous lesson where we talked more in detail in terms of if, elif, and else. If you struggled with this challenge, then have a go at pasting the code that's in the solution into the Thonny code editor. And instead of having the BMI being a worked out value, just set it to some different numbers. So for example, if we start out testing, if the BMI is equal to 18, which of these will it fall into? Then we can click on the debug, step into each of these, and you can see that when it evaluates this condition, is the BMI less than 18.5? Well, 18 is less than 18.5, so this is true. And in that case, it's going to execute this line of code. So it's going to print out your BMI is 18, you're underweight. and then it's done. That's the end of the code. Now, if we change this to say 22, however, and we click on debug, then it's going to evaluate the first condition. Is 22 less than 18.5? That's going to be false. So then it skips to the next elif that it can find, and it checks whether if the BMI 22 is less than 25. So now it's going to execute this print statement. Have a play around with that if it's still a little bit mysterious to you. And hopefully once you're done there, then you'll be ready to move on to the next code challenge, which is a little bit more challenging. For all of that and more, I'll see you there. Hey guys, so I've got another code challenge for you. And this one, as the title suggests, this is a difficult challenge. And this is something that I expect some of you might need to spend 15-20 minutes on. Others might need to spend 30-40 minutes on. And it might just be something that you need to have a think about, get stuck, come back to it after a bit of a break, or sleep on it, come back to it the next day. It's not easy, but what I'm trying to say is really, really give it all you have before you check the solution video, because it's a really, really interesting challenge. So the idea is that we want you to write a program that works out whether if any given year is a leap year. We know that a normal year has 365 days, but leap years have an extra day in February. And the reason is actually really, really interesting. If you're interested, there's a really good explanation of how leap years work and why we have them at this YouTube link. So just go ahead and copy this URL and check it out. Now, the way that you work out if a given year is a leap year, so let's say we pick one out of thin air, 2020, is that on every year that is evenly divisible by 4, so that means divisible by 4 with no remainder, then that is a leap year. But except the years that is also evenly divisible by 100, unless the year is also evenly divisible by 400. Now, 2020 divided by 4 is equal to 505. So it's evenly divisible by 4. There's no remainder. But the rule says that even if it's divisible by 4, if it's evenly divisible by 100, then that is still not going to be a leap year. So let's try that. 2020 divided by 100 equals 20.2. So this is in fact not evenly divisible by 100. So that means it is still a leap year. But then it says unless the year is also evenly divisible by 400. So 2020 divided by 400 is not evenly divisible. So it is in fact still a leap year. The trickiest part of this entire challenge, I would say, is getting your head around these 3 sentences. A year that is divisible by 4 with no remainder is a leap year, except if it's also divisible by 100. In that case, it's no longer a leap year, unless that year also happens to be evenly divisible by 400. Then it is still a leap year. What I recommend doing is if English is not your native language, then have a look online for the rules for determining a leap year in your own language, because these words, except and unless, are so integral to how this algorithm works. And you really, really need to understand exactly what it means. Then what I recommend you doing is to go ahead and create a flowchart, just like what I've done in previous examples. Head over to a website like draw.io, or simply just write it on a piece of paper. Draw it out and visualize what this actually means in terms of your code. Now, if you really get stuck on that, I've also created a flowchart for you. So if you actually get stuck creating the flowchart, there is one there that you can refer to as well. But it's a really good exercise creating your own flowchart based on what it is that you want your program to do. And your algorithm or your code should correctly tell us whether if it's a leap year or not a leap year. So it just has to print out leap year if it is, like 2400. And if it's not a leap year, like 1989, then just print not leap year. This is the time to pause the video and really give this challenge everything you've got. I'll see you back here once you're done. All right, so how did you get on? As I mentioned, this is a really difficult challenge. If you haven't managed to solve it, then try to come back to it a little bit later on and spend more time on it. This is a decisive moment. Don't give up on yourself. Keep going. I'm always going to be here for you with the solution. You're not going to get stuck. It's really, really important to try and solve it yourself. Now, the first thing I mentioned is turning this rule for determining whether if a year is a leap year or not into a flowchart. So I've created one which I linked to in the challenge, and it's very simple. We start off by asking ourselves, is a particular year that we have in mind, let's say the year 2000, is it cleanly divisible by 4? Which means, can you divide it by 4 with 0 remainder? Well, if the case is no, then it's already definitely not a leap year. But if the case is yes, then we have to ask ourselves some more questions. Namely, can we divide it by 100 with no remainder? Well, if we can't, then it's definitely a leap year. But if we can, then we have to check yet again. Can we divide it by 400 with no remainder? If the answer is yes, then it's a leap year. If the answer is no, then it's not a leap year. Let's try and code that logic out. Keep your flowchart up somewhere so that you can write your code while referring to the diagram. We start off by checking whether if the year that came in through the input is divisible by 4 with no remainder. And you might remember from our previous code exercise that the way we do this is using the modulo. So year modulo 4 will give us the remainder. So if the remainder is equal to 0, well, in that case, it's cleanly divisible by 4. And you can check this out yourself in the console. Let's say if you have 8 modulo 4, 4 goes into 8 cleanly, there's 2 4s in an 8, the remainder is 0. Whereas 9 modulo 4, 4 plus 4 is 8, remainder 1. So if the remainder from the year divided by 4 is equal to 0, then it is cleanly divisible by 4. So in this case, we'll have to go into yet another if statement. But if it's actually false, then it's definitely not a leap year. So the else statement that matches this if statement is going to tell us for sure that this is not a leap year. But if it is true, then we have to check the next thing. Is it cleanly divisible by 100? So we check if the year modulo 100 is equal to 0. And if the answer is yes, then we have to check that year against another question. But if it's no, then it's definitely a leap year. In this case, that will lead to an if statement if it's true. But if it's false, then we can simply print leap year, because that's what it's going to be. The final question that we have to ask ourselves about the year is it cleanly divisible by 400? So now if year modulo 400 is equal to 0, well, in this case, if it is true, then it's definitely a leap year. If it's false, then it's definitely not a leap year. So we can print leap year if it's true. Otherwise, or if it's false, then we can print not leap year. And that's it. That's all the code that you would need in order to represent this logic. Now, there's plenty of other ways that you could have written your code, but this is probably the most readable. Now, if you've written some different code, but it still uses these rules to work out whether if a given year is a leap year and it's correct, then that's fine as well. There's plenty of ways that you can solve this challenge. The most important thing I want you to take away from this code exercise is that you can turn any sort of logic into a flowchart to be able to visualize it. And once you've got your logic straight, then converting it into code is much, much simpler. If you haven't figured out the logic and then you try to start writing code, then it's going to be a mess. So first, get to the stage of being able to create your own flowcharts and then take those flowcharts and turn them into code. If you got stuck on this challenge or if you didn't manage to complete it for some reason, head back to it now and give it some extra attention because this is really, really important. It's in these moments, these code challenges, where you're actually going to level up as a programmer. It's not during the tutorials. It's not during the videos where I explain things to you. It's where you actually write the code yourself. I hope you had fun on this code challenge and you managed to complete it, be it with hints or without hints. On the next lesson, we're going to take the if statement one step further, and I want to show you how you can have multiple if statements and test for multiple conditions. So for all of that and more, I'll see you on the next lesson. Now, in the last lesson, we saw how we could use if, elif, else to check for multiple conditions. But in this case, we're only checking one condition, even though we have multiple. Because if this first condition is true, then we would do whatever it is we need to do, and then we would bypass everything else. Now, what if you're in a situation where you need to check for multiple conditions, even if the previous one was already true? Coming back to our roller coaster ticketing problem, if you're going on a good roller coaster ride, you'd probably want to keep a picture for the memories, right? And our roller coaster is no exception. We want to be able to charge users an extra $3 if they want to purchase a ticket that includes a photo. Now, this is quite interesting because this is completely independent of their age or their height. Even if we've already gotten their age and height and determined their ticket price, this is an extra question. Do you want a photo or not? Yes or no? If you do, then we're going to add $3 to your existing ticket price. To do this, we would write multiple if conditions. If condition 1 is true, then do A, but then the code is going to go to the next case and check if condition 2 is also true, in which case it will do B, and if the final condition is also true, it's going to do C. Whereas on the example on the left here, only one of these things, A, B, or C, will be carried out. Comparing the example on the left, where we're using if, elif, else, only one of these things, A, B, or C, will be carried out. But on the right-hand side, all three conditions are checked. And if it so happens that all three conditions are true, then A, B, and C will all be executed. Currently, our code operates like this. We check for their height. If they're over 120 centimeters, we check their age. And depending on their age, we give them a different price ticket. What we now want is, even after we've checked for their ticket price, we want to ask them a question. Do you want photos with your ticket? And if the answer is yes, then we're going to add $3 to their bill, no matter which type of ticket they've got. And finally, we give them the total bill. If they say no, then we jump straight to the total bill and just tell them the price of their ticket. So how do we implement this in our code? Well, first, let's change these print statements. Instead of giving them the bill at each of these steps, I'm going to tell them which type of ticket they're eligible for. So the next thing to do is to ask them whether if they want a photo or not. So I'm going to need to use an input. But the question is, where do I put that? Now, the correct answer is that it has to be at the same indentation level as this if block. So you can imagine this whole thing with the if, elif, and else as sort of belonging together because they all relate to one thing. what is their age and which type of ticket are they eligible for. Now, outside of that if statement, I'm going to create an input and ask the user, do you want a photo taken? Type Y for yes or N for no. And then I'm going to save their input inside a variable called wants photo. So now I'm going to use an if statement to check what their answer was. If it was true, then I'm going to add $3, and if it was false, I'm just going to skip to giving them their ticket price. So here is where I write my if statement. Notice how it's at the same indentation level as this previous set of if statements, but it's not at the same indentation level as this set of if statement. So essentially what's happening is once I've checked their age, then I'm going to check whether if they want a photo or not. And this is going to apply to everybody, no matter their age. So if wants photo is equal to Y, well, in this case, I'm going to go and add $3 to their bill. But how can I add $3 to the bill when I don't have a variable to vary? So instead of using these print statements, I'm going to create a variable up here called bill, and I'm going to set it to equal 0. Now, in addition to printing to the user how much their ticket is, I'm going to set the bill to the price that they're supposed to pay. So if age is less than 12, bill is equal to 5. If age is less than 18, then bill is equal to 7. And finally, for everybody else, the bill is equal to 12. So now, depending on these conditions, the variable bill is going to be changed to a different number. But once we land in this if statement, I'm going to have to add $3 to their bill, no matter which value it is at the moment. So effectively, what I want to do is bill equals the current value of bill plus 3. So if bill was 7, then this new value of bill should be 10. If bill was 12, then it should now be 15. Now in Python, as well as many other languages, there's actually a slightly shorter way of writing this. When you want to increase the current value that's held in a variable and you want to save it back into the variable, you can simply write plus equals. So bill plus equals 3 is the same as bill equals bill plus 3. Now, no matter what the value of bill is before it reached this if statement, I'm still going to add $3 to it. Now, after this if statement is completed, I don't actually have to write a companion else statement, because in this case, if the answer is no, then we're simply going to do nothing. We're not going to do anything to the bill. Instead, I'm just going to skip ahead and print to the user their final bill. And I'm going to use fstrings to insert the value that the bill variable has into this print statement. Now, for your code to work, the indentation matters a huge deal, because the computer will think you want it to do different things depending on the indentation. So notice how this indentation shows that this bill plus 3 is to be executed when this condition is true. But this print statement is not indented to the same level, and effectively it's going to happen after this if statement has been executed. So you can play around with indenting this print statement, unindenting it, and see what the difference is. But now I'm going to go ahead and hit Command Enter or Control Enter on Windows to run my code. And I'm going to go ahead and try and get a ticket. So let's say that I am 21 years old. It tells me that adult tickets are $12. And then it asks me, do you want a photo taken? So yeah, I would love to have a photo taken. And it tells me that my final bill is 15. So I forgot a $sign here, but effectively it's now added the $3 to the $12 because of this additional if statement. So if this concept is still a little bit confusing to you, then I want you to really study this flowchart and just look at the difference and visualize it. Because the if, elif, else statement is only ever going to be true in one of these arrows, right? You can't be less than 12 and 18 and over. And similarly, it doesn't make sense for you to have two different ticket prices. But with the want photos, this condition has to be asked no matter whichever branch they landed on. So it's completely separate from this if statement. And once you've had a look at this flowchart, then compare it against the code. And the way that the code works should be a lot more obvious. And once you're happy with the code and this concept, then I want you to head over to the next lesson where I've got a code challenge for you. So for all of that and more, I'll see you there. All right, guys, are you ready for another challenge? In this challenge, you're going to be building a pizza order program. So we're going to ask the user what size pizza they want, small, medium, or large, whether if they want to add pepperoni to it, and whether if they want extra cheese. So based on the user's input for each of these variables, and the input's going to come in the form of a single capital letter S, M, or L, Y, or N. Based on that input, we're going to try and figure out what their final bill is going to come to. And you can take a look at the prices over here. So if you want to add pepperoni for a small pizza, it's $2, medium or large pizza is $3, and extra cheese is $1 for any size. So you're going to use what you've learned about multiple if statements, as well as everything from previously, in order to be able to create this, so that if the user types in, for example, this input, large pepperoni with no extra cheese, then it should print out your final bill is $28. So have a look at the examples and the hints and go ahead and solve this coding challenge. All right, so this one shouldn't be too hard. And we're going to start off by creating our first if statement, where we're going to check what is the size of the pizza that they chose, so we can assign the price to that pizza. If the size is equal to S, that means they ordered a small pizza. Well, in this case, the price should be $15, right? Now, we're going to create a variable up here before the if statement so that we can keep track of the bill. So size S, the bill is going to be increased by $15. Now, you can, of course, simply just set the bill to $15 in this case, but because we've got a lot of things that can change the bill, it's easier to simply just add 15 to what it is currently, using the plus equal sign that you learned about. Then we're going to check with an elif. Elif the size is equal to M, so if they chose a medium pizza instead, then the bill is going to increase by $20 instead. And finally, for all other cases, namely if they got a large size pizza, then we're going to increase the bill by $25. Now, notice how here you could have also used an elif and said elif size is equal to L. Well, in that case, the bill increases by 25. And you don't actually need an else statement. It's not required. If you feel like it's easier to read like this, small, medium, large, and what should happen for each case, then you can just leave it like this. But of course, there is an argument to be made that the user might have typed something wrong, right? They might have typed a lowercase letter, they might have typed a completely different letter. So in future lessons, we're going to show you how you can catch these cases and how you can deal with it. But for now, let's just keep our program simple as possible. If they type the wrong letter instead of S, M, or L, then we're just going to overcharge them. So now that we've established what the basic price for their pizza is, we're going to look through the add-ons. We're going to see if they said they wanted to add pepperoni. So if add pepperoni is equal to Y, well, in that case, we're going to need to check if they have a small pizza or a medium and large pizza, because the price is different. So we're going to have a nested if function in here. We're going to say if add pepperoni is equal to Y, and then if the size is equal to S, well, in this case, we're only going to add $2 to the bill. But if the size was any other size, basically medium or large, so we can catch that using just an else statement instead of creating 3 separate if size is S, if size is M, etc. And in this case, we're going to add $3 to the bill. So now we've got this case covered. The final thing is whether if they said they wanted extra cheese or not. So if they did, in fact, want extra cheese, well, in that case, all we have to do is just add $1 to the bill. So these are 3 separate sets of if statements. This one, and this one. And by the end of all of these if statements, as long as we're at the right indentation level, namely right next to the gutter here, then we can go ahead and calculate their bill and print it out for them. So we can say print, and I'm going to use an F string to insert the bill in here. Print your final bill is, and then I'm going to add a $sign, and then inside the curly braces, I'm going to put in the current value of the bill after all of these calculations. So did you manage to get it right? Did you manage to use a combination of if statements and elif statements, nested if statements, or did you do it in a different way? And it's totally cool if you did. As long as it does what it's supposed to do, then it doesn't really matter whichever format of your code you decided to go for. And as a matter of fact, there's loads of ways that you could have written this code to get this functionality. Some of them will be slightly more readable, some of them will be slightly less readable. So it's a case of you making a good judgment on that and choosing the code that makes the most sense to you. Now, in the next lesson, I want to talk a little bit about combining different conditions so that we can use something called a logical operator to check for multiple conditions in the same line of code. So for all of that and more, I'll see you on the next lesson. Now, up to this point, you've seen us use if statements, else statements, elif statements, multiple if statements, as well as nested if statements. But the thing that we haven't been able to do thus far is to check for multiple conditions in the same line of code. So how would we be able to combine different conditions and say, well, is the pizza large and the user wants pepperoni and extra cheese all in the same line of code? Well, to do this, we would need to learn about the logical operators. So there's 3 of them that are really useful: and, or, and not. So let's take a look at the first one. When you combine 2 different conditions using an and operator, they both have to be true, both A and B, for the entire line of code to be true. If just one of them is true, say A is true and B is false, or A is false and B is true, then the overall thing evaluates to false. So if we take a look just inside the console, and in fact I'm going to clear the console, and I write some code here. Let's say that A equals 12, right? Now let's say that I wanted to check whether if is A greater than 15? Well, that is going to be false. Now, what about is A greater than 10? Well, that's going to be true. Now, if I combined this using an AND statement, I could say, well, is A greater than 10 and A is less than 13 and hit enter, then I would get true, because both A is greater than 10 and A is less than 13 are true. So in this case, when both conditions are true, then this entire line gets evaluated to true. But see what happens when just one of them is false. So is A greater than 15 and A less than 13? A is greater than 15 is false, A is less than 13 is true, and now we get false. So that's what happens when you combine different conditions using AND. Now, if you only needed one of the conditions to be true, then you could use the OR operator instead. So if C or D were true, or if they're both true, then it would evaluate to true. It's only when both C and D are false does this statement actually become false. Now the final one is the not operator. And all that this does is it basically reverses a condition. So if the condition is false, then it becomes true. If it's true, then it becomes false. If I wrote not, and then I wrote the condition, A is greater than 15, A greater than 15 is definitely false. 12 is less than 15. But by putting the not there, it's going to reverse this, so going from false to true. So when I hit enter, you'll see it is now true. Coming back to our roller coaster ticketing, let's say that the roller coaster company decided that for everybody who was having a midlife crisis, they would give them free tickets. And according to Wikipedia, midlife crises typically occur when you're 45 to 55 years old. Let's see if we can incorporate this into our code. So let's say that in addition to these existing price categories, what if you had to add a separate price category for those people who are aged between 45 and 55, and those people get to ride for free? Do you think you would be able to change the code using what you've learned about logical operators in order to incorporate this addition to our program? Pause the video and give that a go. So we've currently got 3 conditions: age less than 12, age between 12 and 18, and finally everybody else. Now, instead of just finishing up there, let's go ahead and add another elif. And here we're going to combine 2 conditions. We're going to say if the age is greater than or equal to 45 and the age is less than or equal to 55, then we get to catch that midlife crisis window. Well, in this case, we're going to print something like, we're going to say everything's going to be okay, have a free ride on us. And in fact, we don't need to modify the bill in any way, because we know that with if, elif, and else statements is that once this condition matches, then everything that's inside this block, so everything that's indented inside this elif, is going to be carried out, namely printing this out, and then it's going to skip the rest of this if-else block and continue on. Now, if they want a photo, they still have to pay $3, but at least their ticket is free. And we've been able to do this because we know about the AND logical operator. In the next lesson, we're going to practice using logical operators some more by completing another code challenge. So for all of that and more, I'll see you there. All right, guys, it's time to show what you're made of. Here's another code challenge. And this one is, again, another difficult challenge. And the arms really show you just how difficult it is. But you're going to flex and you're going to get stronger. And it's only through struggle that you're going to become a better coder. So in this code exercise, we're going to build a love calculator. And the way that it's going to work is the same method that I used when I was 10, pretty much. And I really recommend reading up on this particular BuzzFeed article, which is, of course, very reputable, and it's going to tell you exactly how this program is going to work. So once you've managed to scroll past all the GIFs, it will tell you the method. So you write your name, his or her name, and then the words true and love. Now then, you're going to count the number of times TRUE occur in both of your names, and then you're going to count the number of times LOVE occur in both of your names. Once you've got those numbers, so here TRUE adds up to 6, LOVE adds up to 3, then you'll get the percentage that you are compatible with this other person. So not only do you get to learn programming on this course, you also get to discover your destiny. The idea is that we're going to convert this very time-consuming process into a computer program. So once you've understood how it works, you're going to write the code for it. Now, in order to be able to calculate the love score, there's two important things that you should read in the hint. One is you will need to use the lower function. And all that this does is it takes a string. Let's say we've got the string Angela. And notice how that first letter is a capital A. If I write dot lower parentheses, then it will reduce all of the capital letters to lowercase letters. And if you were wondering how you would have known to use this, then you can head over to this Stack Overflow question in which somebody asks exactly this question: how do you turn something that's uppercase into a lowercase character in Python? The second function you'll need is the count function, and this will give you the number of times a letter occurs in a string, which is super useful when it comes to this particular challenge. So again, let's use our string Angela, and then I'm going to write count, and then in between the parentheses, I'm going to specify what it is that I want to count. So let's say I want to count the character A inside this string, and I hit enter, it comes up with 1. Even though you can see there's actually 2 A's in this string, in my name, it only counts 1 lowercase a. So that's why this first step was super, super useful. So let's say lowercase name equals Angela dot lower. And then let's go ahead and do lowercase name dot count. And then we're going to count for A again. Now you'll see it gives us 2 because we were able to convert everything to lowercase and then use the count function to check the number of times the character A occurs in this string. And again, I've linked to a Stack Overflow question, which is how you might have found out to use this count function and how you might use it in terms of code examples. Now, there's a second step to this challenge because not only do we want to know the love score, we also want to give the user an interpretation. So the interpretation is here. For love scores that are less than 10 or greater than 90, the message is going to say your score is X, and of course replace that X with the actual score. You go together like Coke and Mentos. Now, if their love score was between 40 and 50, the message is going to read your score is whatever it may be. You are all right together. And finally, for all other scores, the message is just going to give them their score. Your score is XYZ. In this case, there's 2 inputs, somebody's name and then somebody else's name. And then you're going to check for the number of times TRUE occurs in both of those names, LOVE occurs in those names. Then you're going to combine these digits together to get the love score. Pause the video now, have a look at everything that's in the instructions, read it all, and then go ahead and give that a go. All right, so the first step is to work out the love score, right? So we need to figure out how many times each of these letters occur in these names. The first thing that we need to do is to combine the names because we're looking for the number of times, let's say T occurs in these names, and we're treating them as one string, right? So I don't want to check it separately and then have to add it together. So let's call it a combined string, and let's set that to equal name1 plus name2. And this is just going to concatenate those 2 strings together. So we'll be able to check them only once. Makes it more efficient, right? The next step is to guard against cases where the user is inputting their name like this, which many people do, or they might even write it like this. So we have to turn everything into lowercase. So let's call it lowercase string. And that will be combined string dot lower, just as I demoed previously using this lower function. So now we've got everything in lowercase, we're going to start checking for this first word, TRUE. So let's first check how many times the letter T occurs in this lowercase string of both people's names. So we can say lowercase string dot count, and then inside the parentheses, we specify the string we're looking for, which is t. And then I'm going to save this to a variable, which I'll just call t again. And then we're going to repeat this several times. Hopefully, for practice sake, you'll type it all out. But in my case, I'm just going to copy and paste it, which is usually error prone, but we'll try to be careful. So now that we've got the number of times t occurs, r occurs, u, and e occurs, we can now add it all up. So let's say true equals t plus r plus u plus e. So now we've got the first digit of our love score. And we have to go ahead and do the same thing for LOVE. So again, for time's sake, I'm just going to copy that and then go ahead and change this to LOVE and LOVE. And then I'm going to go ahead and calculate the total for that, which is going to be L plus O plus V plus E. And now I've got both of these numbers, and I'm going to try and concatenate them together to achieve this 2-digit number. To do that, I'm going to create a love score variable that's going to keep hold of this. And then I'm going to say true plus love. And remember that at this stage, both true and love are actually integers. That's how we were able to add them together. So if I want to turn them into a string in order to be able to concatenate them together, I have to convert them to strings. The final thing we have to do is just to go ahead and print this love score. So we're not going to print anything else for now. Let's just go ahead and test it out. So let's run our code. And let's type my name and then their name, Jack Bauer, of course, and then it gives us the score. So 5-3. So that means everything so far has pretty much worked. So now all we have to do is use our knowledge of if statements to give a corresponding interpretation or a message. If the score is less than 10 or greater than 90, so if love score is less than 10 or love score is greater than 90, so we're using that logical OR operator here to check if either this condition or this condition is true. And if you find it helpful, which I usually do, it's easier to wrap these conditions in their own set of parentheses. Now, Python doesn't actually care. Either method works, but for us humans, this is a little bit more readable. So under this condition, what we're going to print out is your love score is, and then we'll insert the love score variable here. And we're going to, of course, be using f-string, so let's add that. And then we're going to write you go together like Coke and Mentos. So that's our first condition done. Now, the next condition is, what if their love score is between 40 and 50? So let's go ahead and add an elif here. Elif, the love score, is greater than or equal to 40, and the love score is less than or equal to 50. So that catches the cases where the love score is between 40 and 50. So both of these conditions must be true for this statement to fire. And in this case, what we want to do is we want to print out this sentence. So your score is, let's just insert the love score in here. Your score is this particular love score. You are all right together. Now, the final thing we said is If it doesn't match any of these conditions, then the message is just going to be their score. So that means we can catch everything else using an else statement, and we can simply just print your score is this particular number. Now, at this stage, you might think you're done, but if you actually run it, you're going to get an error. So let's go ahead and test it with the same names as before. You can see that we get a type error on line 27, and it says that the comparison less than is not supported between instances of string and int. So the problem here is that in order to concatenate these two numbers, we had to turn them into strings. So that let's say that this number was equal to 5 and this number was equal to 6, then instead of getting 11, which is not what we want, we actually get 56 because they're both strings, and these strings get concatenated together. But the problem occurs on the next step. Because we want to compare the love score against an actual number, then if it's a string, it's not going to work. So in order to solve this, then we actually have to convert the love score into an integer. So you could use a separate step. So the integer score equals int, and then we wrap it around the love score. Alternatively, and a lot easier, is to simply just wrap that whole line inside a set of brackets and convert the whole thing into an integer on the same line. It depends on how comfortable you are with this code as to which option you'll choose. Now that we're done here, let's go ahead and run our code again, and let's just check it. Your score is 42, you are all right together. So now our code seems to be working, and we've now completed this code challenge. How did you get on with this challenge? Did you manage to get everything right? Did you get stuck at certain places? Have a think about which parts of this challenge were the hardest, and see if you can review some of those concepts so that the next time you encounter them, you'll be able to tackle them with confidence. Hey, you've reached the final project. And as you've seen at the beginning of today's lessons, I showed you what we're going to be making, which is a sort of choose your own adventure game. I don't know if you've ever read those choose your own adventure books where you flip to a different page if you make a particular choice, and then the story kind of evolves as you make your choices. Now, we're going to make a very simple version of that using what we've learned about conditionals, if, else, elif statements, as well as everything we've done previously. So you've already seen what the final outcome should look like, and if you want to review it again, just head over to treasure-island-end.appbury.repl.run, and here you'll see essentially the game in action. So it starts off asking you, you're at a crossroad, do you want to go left or right? And then you have to type your choice. If you selected left, then it's going to take you to a lake, and it asks you whether if you want to wait for a boat or swim across. So let's go ahead and wait for a boat. And then the final step is it asks you, which door would you like to go through, red, yellow, or blue? Now, depending on your choice, you'll either end up with game over or you'll end up with winning the game. So the basic setup for this game looks something like this. And I've included a link to this flowchart in the starting REPL. So repl.it/appbury/treasure island start, and of course you'll find all the links in the course resources as always, but if you scroll down there's a link right here that takes you to this flowchart. Now the first question you're going to ask the user is to make a choice between left and right. Now you can use my wording if you want. You're at a crossroad, where do you want to go? Type left or type right, but I think the fun part of this challenge is really creating your own story, right? But somehow get them to choose between left and right. If they choose right, or any other condition for that matter, tell them that they've lost, game over, for some sort of reason. In my case, if they had chosen right, the reason is because they fell into a hole, game over. But I think you're far more imaginative than I am, so go ahead and use all of those skills and make your game really fun. Now, if they've chosen left on the other hand, then we're going to take them to another question that asks them whether they want to swim or whether if they want to wait for a boat. And if they swam, then it's going to be some form of game over. There's crocodiles, there's whatever it may be, but they can't continue. But if they chose wait, then we take them to the third and final question, which asks them to choose between 3 doors. And if they choose any door other than the yellow door, then they would lose, but if they chose the yellow door, then they somehow win. Now, notice how each of these just says game over, left or right, but the idea is really to use your creativity and make this game really your own. Now, one thing to remember though is that when the user types in a answer, let's say left or right, they might type it like this with an uppercase R, or they might type it like this, all lowercase. Have a think about how you might make sure that no matter which version they typed, you're still going to be able to catch their command, essentially. So have a think about what you've learned in the previous lessons and take a look at this flowchart. Then head over to the starting project and you can get started writing your code. Now, if you head over here and what you see is sort of like a mumbo jumbo bunch of characters, then the reason is probably because there's not enough space for this ASCII art of a treasure chest to display. So you can either do, as I did, reduce the size of the console, or alternatively, and probably easier, is to change the layout to stacked, make it go at the bottom, collapse this left-hand pane, and then you've got as much space as you have to work with. Now, ASCII art is really cool because it basically just uses a bunch of characters that you know and love, like the comma and the equal sign and all of these things that together make up a picture. And you can find your own ASCII art if you just go to ascii.co.uk/art, and you'll see a whole bunch of different topics, and they've grouped a lot of things together into individual pages. So if you wanted a rhino ASCII art, then you can find a whole bunch of rhinos that people have drawn. But the easiest way is, of course, using Command F if you're on a Mac or Control F if you're on a Windows machine, and then just search for the thing that you want. So, for example, I went and searched for treasure, and down here I found this brilliant treasure box ASCII art, which is what I'm using to print inside this print statement. Now, notice how there's 3 single quotes that are at the start and there's 3 single quotes at the end. Basically, what the single quotes allow you to do is to create multiple lines of a string, essentially. So notice how if I go ahead and delete all of these single quotes and I only had a set of double quotes, then it actually doesn't quite work. It gets quite confused because it thinks that this is where the line ends, but in fact I wanted to print all of this out. So to do that, instead of using a double quote, I use 3 single quotes, and at the very bottom I tell it, well, this is the end of my multi-block string by using 3 single quotes as well. So have a go at running that and you should be able to see that in your console you get this little Treasure Island ASCII art being printed along with the 2 sentences that begin the game. So have a look at the flowchart, have a play around with the ASCII art, and also have a look at the final version of the app so that you can go ahead and create your own version to complete this challenge. Pause the video now and give that a go. Alright, so let's see if we can replicate the functionality or the logic that's shown in this diagram into our Treasure Island game. So the first thing it has to do is we have to ask the user whether if they want to turn left or right. And after we ask the user this question, we're going to want to capture their input, right? So let's go ahead and create an input function and ask our question. Now, notice how when I use my double quotes around my string, the double quotes that are inside the double quotes are interpreted as code because it actually thinks that this is the end of the first string. this is the second string and this is the final string. This is how the computer is going to see it. Now, previously you saw that we could do the trick where we change this to single quotes instead. But if, like me, you have this case where you have the your with the apostrophe, then it's going to think that this is actually the end of the first string, this is the second string, and this is the third string. So this doesn't actually really help us. Now, what we can do when we want to tell our computer that what I'm writing is actually not code, just see it as text, you can get it to ignore a symbol afterwards by using the backslash. So this way, it basically escapes this string and it will see it as text. And now we have a complete string like this, and this is just going to be interpreted as text because we told it to with the backslash. Now, of course, there's other ways that you could have gone around this. You could have just simply said you are at a crossroad rather than using the apostrophe. But more often than not, you'll need to use a symbol that you'll need to escape, and you can do that with the backslash. So that's just a quick tip. Now, at this point, the user is going to type a message, left or right. So let's go ahead and save that to a variable. Let's call it choice1 equals their input. Now, remember how I said they could be typing the answer as right or as right. So how can we make sure that when we're doing our checks using the if statement, we ignore the casing? Well, one way of doing this is we can simply use the lower function to change their input. No matter how they wrote it, right, or right, it should all be converted into lowercase to this version. That way, we have one thing that we can consistently check for in our if statement, which is coming up next. So we can say if choice1 is equal to, remember the double equals is checking whether if left-hand side and right-hand side is equal, and the single equal sign is assigning the right-hand side to this particular variable name. Now, if choice1 equals the string right, then it's pretty much game over for our player. So let's go ahead and add our colon and print something like game over. Of course, we can elaborate this a little bit more as to why was it game over. Well, because you fell into a hole. This is like the E.T. game from the 80s. Lots of holes. So you fell into a hole, game over. But what if they had chosen left instead? Well, that takes them on to the next question. So that's the option that will allow them to continue along the game. Now, in this case, we could use an else statement and say, well, if they didn't choose right, then they probably chose left, right? But they could have also chosen like a option that was completely not listed. They could have just written something like this, and it would still trigger the else statement. So what we should actually do is to switch it around. So namely, we should say if choice1 is equal to left, well, in that case, then they continue in the game. But otherwise, namely, if they chose right or anything else for that matter, then it's pretty much game over. So this format makes a lot more sense if you want to continue along the left side of the branch this way. Now, another thing that you might have realized because we learnt about combining different conditions is instead of using the dot lower to change the input to lowercase, you could have also said if choice is equal to left or if choice1 is equal to left, spelled like this. That will both work. But I think in terms of succinctness and less code writing, I think this makes a lot more sense to me. So I'm going to continue with this version, but if you did it the other way, that's perfectly valid as well. Now, if their choice 1 was left, then they get taken to the next question. Do you want to swim or do you want to wait? So let's go ahead and continue the game and create another input. In this input, we're going to ask them a question and say, you've come to a lake. There is an island in the middle of the lake. Type wait to wait for a boat. Type swim to swim across. Cool. So we've actually got the same problem as we had before, namely that this is being interpreted as code rather than as a continuous single string. So do you remember how we fixed this previously? And if you got stuck on this, I recommend having a go at this yourself before I show you the answer. All right, so previously we said we were going to switch it to single quotes instead, so that these double quotes become interpreted as just normal strings. But of course we've got this you've. We could of course change it to you have instead of you've, but if we want to escape this string, we just add a backslash, and now everything is colored in this sort of pinkish color to indicate it's all interpreted as a string, which is exactly what we did previously. Now, in terms of this input, they're going to type wait or they're going to type swim. So let's go ahead and lower the casing for it as well. And then we're going to save it inside a choice. We're going to say choice 2. Now, be really careful and mindful of your indentation, because if you wrote it like this, then it's going to be creating some errors for you, because this choice 2 input line has to run when this choice 1 is equal to left. Otherwise, we're going to get an indentation error. So let's go ahead and indent it here to show that this part is inside this if statement and will only be executed if this is true. And then we get to check our choice 2. So if choice 2 is equal to wait, then it means that the game will continue. But else, so if they typed swim or anything else for that matter, then the game is going to end. So we're going to print and tell them that something terrible happened. You got attacked by an angry trout. Game over. Now we can continue along this path. So we're down to here now. And the final question we're going to ask the user is, which door do they want to choose? So here I'm going to use an input to send them the message that you arrive at the island unharmed. There is a house with 3 doors, 1 red, 1 yellow, 1 blue. Which color do you choose? Now I'm going to save their choice inside a variable called choice3, lowercase the answer that they provided, and finally I'm going to use if, elif, and else to check which one they chose. So if choice 3 is equal to red, elif, choice 3 is equal to yellow, elif, choice 3 is equal to blue. And then I've got a else. So here are 4 possible things that could happen. If they chose red, then I'm going to tell them that it's game over, but it's going to be some sort of creative version of game over. So maybe something like it's a room full of fire, game over. If they chose yellow, on the other hand, well, that's going to be the room where the treasure exists. So I'm going to print you found the treasure, you win. If they chose blue, they also end up with game over, and I have to give them a different reason. Now, if you had decided that if they chose anything but yellow, the way that they're going to game over is the same. Say if you chose red, it's a room full of fire, game over. If you chose blue, it's a room full of fire, game over. Anything else, it's also going to be fire, game over. Well, then you could just use if and else. But if you wanted each choice or each door to have a different outcome for the user, say the red door has fire, the blue door has beasts, and if they chose the wrong door, then they're going to get something like, you chose a door that doesn't exist, game over. So can you see that depending on whether if you want to give the user a different print statement based on their choice, then you would use if, elif, else. But if you actually just wanted to give them the same feedback, which is game over, then you could just use if and else. Now let's run our game and just make sure that it works. So I'm going to go left because I know it continues, and then I'm going to wait for the boat, and that allows me to get to the final condition, and if I choose yellow, I know that I'll win. Now, if you want to change the formatting, because having the input at the end of the sentence doesn't look as good as letting the user type it on a new line, like what we've got here, then you can simply, if you remember, just add the new line, which is \n, at the end of your inputs, like so. So how did you get on with this challenge? And if you didn't manage to do it right, or if you've done it right, go back and try and modify it. See if you can add some more conditions, or see if you can make the game over messages a little bit more interesting than what I've written. See if you can modify and make it really your own. Have fun with that. And in the next lesson, I've got more exciting things coming up for you. So hopefully you've scheduled some time for tomorrow to complete the next day's lessons. But for now, it's good night from me.
Hey, I hope you had fun building the Treasure Island project. Now, remember that the most important thing when it comes to programming and learning this new skill is to really make the code your own. So with this project, really the sky's the limit. You can take your creativity and run with it. Make the story your own, change it up, change the game. Make it something that you imagine it to be. And I can't wait to play your game. So once you've created your own version, be sure to share it in the comments below so we can all play it and we can all admire your hard work. So have a go at that, and I'll see you tomorrow.